topic of this video is surface area of a pyramid. So what is a pyramid? A pyramid consists of a polygon base and a vertex, which is a point located not in the plane of the polygon base. The height of the pyramid is the length of that segment that goes from the vertex down to the plane that contains the base. So that forms a perpendicular with the base. That is the height of our pyramid. Now we're going to take a look at a specific type of pyramid. We're going to take a look at a regular pyramid. Now, what is a regular pyramid? Well, it meets all the criteria of a general pyramid with two differences. First, our base is itself a regular polygon. So a regular polygon has n sides, and each of the side lengths is equal, as well as each of the angles formed at the vertices of that polygon. And secondly, the vertex is located in a specific spot. It's located, as drawn here, directly above the center of my polygon base. Okay? So that is my height. All right? So we're going to calculate the area of a regular pyramid. We can calculate the area of a general pyramid, as shown on the left, but we'll start off with something that's a bit simpler. That is the regular pyramid. Okay? So we can write the equation for our surface area of a regular pyramid. We can break it up into two parts. My surface area of a regular pyramid is going to be equal to the surface area of the base plus the surface area of the lateral surface. That's the side surface. We've got, if we have n sides to our polygon, we're going to have n lateral faces. And so this is how we can break things down. And what I'm going to do is I'm going to give these descriptions symbols. So for the surface area of a regular pyramid, I'll call it S. And the area of the base, I'll call B. And the area of the lateral surface, I will call L. Now, we learned earlier that for the area of a polygon, a regular polygon, that can be expressed as 1/2 times the apothem times the perimeter, P. And what the apothem is it is the distance between the center of the polygon and the center of one of the sides. So that is our apothem. Forms a right angle with the height. And that is an expression, 1/2 times the apothem times the perimeter. That will give us the area of our base. Now in this example, we have a square base. So we might have thought of simply putting in the area as the base B times the base B, but I want to keep things general. So right now we have a square, yes, but perhaps next time we'll have a pentagon or a hexagon or a septagon or octagon. And putting things in terms of the apothem will allow us to keep this general. Okay, so that's our area of the base. The area of the lateral surface, L, well, that's simply going to be the area of one of our lateral faces times the number of lateral faces. So the area of a lateral face is, we have a triangle, and we call the distance between the center of one of our edges for the polygon base to the vertex, we call that L. That is our slant height. And one can see that there's a relationship between the slant height and the actual height of the pyramid and the apothem. Namely, that L squared is equal to A squared plus H squared, because it forms a right triangle. So the area of one of these lateral faces is 1/2 B, that's a side length of my polygon base, times L, my slant height, and I'm going to multiply that by the number of faces that I have. That's n. In this case, n is equal to 4, but the general case, it's the letter n. Now we can rewrite this as 1/2 A times P. We won't change the first term, but the second term, I'm going to use the commutative property to rearrange this. So I have, now I'll bring the 1/2 out in front, and then I'll have n times b, and then times the slant height. And what we recognize is that we have n times b, that is really the perimeter. B is the length of one side, and I've got n of those sides, so the perimeter is equal to nb. So I now have 1/2 times the perimeter times L. And this is a practical equation that we would use for applying in determining the surface area of our pyramid. It may be difficult sometimes to remember this, so what I usually recommend is that we think in these terms, that my surface area is equal to simply the base plus 1/2 times the perimeter times L. This is the form that I typically encourage students to remember, because we can remember that the area of a base is 1/2 times the apothem times the perimeter. That's a pretty important relationship. So these are equations, and it's helpful to know what the relationships are to summarize them in terms of what all of these are. So my base is 1/2 times the apothem times the perimeter, as we mentioned. My perimeter is equal to n, the number of sides of my polygon base, regular polygon base, times the side length. And of course, L squared is equal to my apothem squared plus H squared. So given several of these parameters, if we need to find one out, we can use that using these relations.